Are we alone in the universe? It's a question that has fueled endless curiosity, countless theories, and an unrelenting search for planets beyond our solar system. In 2016, astronomers made a discovery that brought this search closer to home. An exoplanet orbiting the nearest star to our Sun, Proxima Centauri. Just over 4 light-years away, this planet, known as Proxima Centauri b, immediately became one of the most intriguing places in the cosmos. Could it be habitable? Could there be life? Or is it just another lifeless rock drifting in the vastness of space? Proxima Centauri b is the closest known exoplanet to Earth, making it a prime candidate for study. Unlike many distant worlds that require powerful telescopes to even detect, this one sits right next door in galactic terms. Since its discovery, scientists have been racing to understand its characteristics, its size, orbit, atmosphere, and potential for hosting life. It orbits within its star's habitable zone, the region where liquid water might exist, which raises exciting possibilities. But its reality is far from simple. In this journey, we'll break down what we know about Proxima Centauri b, its discovery, its harsh yet intriguing environment, and whether it could sustain life as we know it. We'll also explore the challenges any life would face there and how future missions might unlock its secrets. Could this planet be a second Earth? Or is it a place where life would struggle to survive? Let's find out. The Alpha Centauri system isn't just one star. It's a fascinating trio. At its heart are 2 Sun-like stars, Alpha Centauri A and Alpha Centauri b, locked in a slow gravitational dance around each other. Then there's Proxima Centauri, a small but powerful red dwarf, orbiting the pair at an immense distance. This makes Alpha Centauri a triple star system, with Proxima Centauri being the closest of the 3 to us. And it's around this dim, flickering red dwarf that Proxima Centauri b orbits, raising the tantalizing question, could life exist so close, yet so far? The journey to understanding Alpha Centauri has been centuries in the making. The first recorded mention of this bright stellar neighbor dates back to the 2nd century, when the Greek astronomer Ptolemy catalogued it among the stars of the southern sky. But it wasn't until 1689 that Jean Richaud, a French astronomer observing a passing comet, realized Alpha Centauri was actually 2 stars, not 1. The discovery of this binary system was a turning point, marking one of the earliest known cases of a double star in astronomy. The story didn't end there. In 1915, Scottish astronomer Robert Innes noticed a faint, separate star near Alpha Centauri and determined it was even closer to Earth than the other 2. This was Proxima Centauri, the dim 3rd member of the system and the closest star to our Sun. At just over 4 light-years away, it became the nearest known stellar neighbor, and a century later, it would reveal something even more astonishing: an exoplanet orbiting within its habitable zone. Proxima Centauri b is a planet that, at first glance, seems eerily familiar. It's slightly larger than Earth, with a mass about 1.3 times that of our home planet. This means its gravity would be just a bit stronger, making it a place where humans could potentially stand without being crushed or floating away. But beyond its size, things start to look very different from Earth. Unlike our comfortable 365-day orbit around the Sun, Proxima Centauri b races around its star in just 11.2 Earth days. That's because it sits incredibly close to Proxima Centauri, only about 5% of the distance between Earth and the Sun. If our planet were that close to our Sun, it would be a scorched wasteland. But Proxima Centauri is a much smaller, cooler red dwarf, meaning its habitable zone is packed in tightly, allowing a planet so close to potentially have temperatures where liquid water could exist. Finding this planet was no easy task. Unlike large, bright exoplanets that can sometimes be seen crossing in front of their stars, Proxima Centauri b was detected using the radial velocity method. Scientists at the European Southern Observatory used an instrument called HARPS, AE, high-precision spectrograph, to measure tiny wobbles in Proxima Centauri's motion. These wobbles were caused by the gravitational tug of an unseen planet, Proxima Centauri b, confirming its existence. With its size, location, and orbit, the big question remains: is this world actually habitable? It sits in the so-called Goldilocks zone, where conditions might allow for liquid water, but there are many other factors at play. Could it have an atmosphere? What about the powerful radiation from its active star? These are the challenges that could determine whether Proxima Centauri b is a promising world or a harsh, lifeless rock. The idea of a habitable zone is simple but crucial when searching for planets that could support life. It refers to the region around a star where temperatures might allow liquid water to exist, neither too hot, where water would boil away, nor too cold, where it would freeze solid. Since all known life depends on water, this zone is often the first place scientists look when assessing a planet's potential for habitability. Proxima Centauri b happens to sit right in this zone around its parent star. Because Proxima Centauri is a much cooler and dimmer star than our Sun, its habitable zone is packed in close. If Proxima Centauri b were orbiting a star like ours at its current distance, it would be a scorching inferno. But around a red dwarf, this same distance places it in the range where surface temperatures could, in theory, allow for liquid water, one of the key ingredients for life. However, just because a planet is in the habitable zone doesn't mean it's actually habitable. There's a lot more to the equation. A planet needs the right atmosphere to trap heat and maintain stable temperatures. It needs protection from harmful radiation. It needs a way to sustain liquid water over long periods. Without these, a planet in the habitable zone could still be completely uninhabitable. So, while Proxima Centauri b is in the right place, whether it's truly a place where life could exist is an entirely different question. For life as we know it to exist, certain conditions need to be met, and one of the most important is the presence of liquid water. Proxima Centauri b sits in its star's habitable zone, meaning it could have the right temperatures for water to exist on its surface. But that's just an educated guess. Scientists haven't yet confirmed whether this planet has any water at all. If it does, it might be locked beneath an icy shell, trapped underground, or spread across a vast ocean, assuming the planet has the right conditions to hold on to it. Another crucial factor is the atmosphere. Without one, any water that might exist on Proxima Centauri b wouldn't stay liquid for long. An atmosphere helps regulate temperature, keeping a planet from turning into an icy wasteland or a scorching desert. It also acts as a shield, protecting the surface from harmful radiation. So far, there's no clear evidence that Proxima Centauri b has an atmosphere at all. If it does, it could be thick enough to support life, or so thin that it offers no protection whatsoever. Temperature estimates depend entirely on whether or not an atmosphere is present. If Proxima Centauri b has one, it might distribute heat and create a more stable climate. But without an atmosphere, temperatures would likely drop to around 40 degrees Fahrenheit, making survival incredibly difficult. Still, some forms of life on Earth thrive in extreme cold, so the possibility of life can't be ruled out just based on temperature alone. One factor working in Proxima Centauri b's favor is its energy source. Red dwarf stars like Proxima Centauri burn at lower temperatures than our Sun, but they also last much longer, potentially trillions of years. This means any planet orbiting a red dwarf, if habitable, could have an incredibly long window of time for life to emerge and evolve. But while the star's longevity is an advantage, it also presents some serious challenges. Proxima Centauri is known for powerful flares, which could make life on its planet far more difficult than it seems at first glance. While Proxima Centauri's long lifespan might seem like an advantage for life, it comes with a major drawback: extreme stellar activity. Red dwarfs are known for their violent temperaments, regularly unleashing powerful flares that bathe their planets in intense radiation. Unlike our relatively stable Sun, Proxima Centauri produces frequent outbursts of X-rays and charged particles, posing a serious threat to any atmosphere or water that might exist on Proxima Centauri. In fact, Proxima Centauri b is bombarded with far more X-ray radiation than Earth, over 400 times more on average. This constant exposure makes it difficult for an atmosphere to survive. Strong stellar winds and flares could gradually strip away the planet's protective layers, leaving it vulnerable to the vacuum of space. If that happens, surface water would either freeze solid or evaporate into space, making life nearly impossible. One of the most dramatic examples of this occurred in 2017, when Proxima Centauri erupted in a flare so powerful that radiation levels around the planet spiked by a factor of 10,000 in just 10 seconds. If Earth were hit with something like that, it could fry satellites and disrupt communications. For a planet like Proxima Centauri b, repeated flares of this magnitude could be devastating, potentially eroding its atmosphere over time. However, Proxima Centauri b does have one factor in its favor: its size. Being slightly more massive than Earth, it has a stronger gravitational pull, which could help it hold on to its atmosphere and any water it might have. Whether this is enough to counteract the destructive effects of Proxima Centauri's flares remains uncertain, but it raises the possibility that life could exist underground or in shielded pockets, safe from the relentless radiation above. One of the biggest challenges to life on Proxima Centauri b is its likely tidal locking. This means that the planet always keeps the same side facing its star, much like how the Moon always shows the same face to Earth. As a result, one hemisphere would be in perpetual daylight, while the other would be trapped in eternal darkness. This setup could create extreme temperature differences, scorching heat on the day side, deep freezing cold on the night side, making it difficult for life to thrive on the surface. However, a planet being tidally locked doesn't necessarily mean it's uninhabitable. If Proxima Centauri b has an atmosphere, winds and weather patterns could help redistribute heat, preventing the day side from becoming a blazing inferno and the night side from turning into a frozen wasteland. Similarly, if the planet has a liquid ocean, currents could carry warmth around the globe, creating a more stable environment, especially near the terminator, the thin twilight zone between night and day, where conditions might be more moderate. Another factor that could affect the climate is a phenomenon called libration. Even though Proxima Centauri b is likely tidally locked, it wouldn't be perfectly motionless. Slight wobbles in its rotation, both side to side, latitudinal libration, and forward and backward, longitudinal libration, could cause small shifts in the amount of sunlight different regions receive. This could help mix temperatures and create more variation in climate, rather than a sharp divide between the two hemispheres. If Proxima Centauri b has the right conditions, an atmosphere thick enough to transport heat, or an ocean to moderate temperatures, then parts of the planet could still be suitable for life. But without these stabilizing factors, its surface might be a harsh and inhospitable place, with one half scorched and the other locked in an icy darkness. A planet's magnetic field can be the difference between a habitable world and a barren rock. Earth's magnetic field protects us by deflecting harmful solar radiation and preventing our atmosphere from being stripped away. Proxima Centauri b, despite its harsh environment, might have a strong magnetic field that helps it retain some level of protection against the intense radiation from its star. Because Proxima Centauri b is likely tidally locked, it was once thought that it might have little to no rotation, which could weaken its magnetic field. However, tidal locking doesn't mean the planet is completely still. It still rotates around its own axis, just in sync with its orbit. That means its core could still be molten and moving, generating a powerful magnetic field, potentially even stronger than Earth's due to the planet's slightly larger size and mass. If Proxima Centauri b has an active core, this could be a crucial factor in its ability to sustain an atmosphere. A strong enough magnetic field could scatter incoming charged particles from Proxima Centauri's frequent flares, preventing some of the worst radiation from reaching the surface. It wouldn't make the planet completely safe, but it could provide a level of shielding that makes underground or deep-sea life more plausible. The question remains, is Proxima Centauri b's magnetic field strong enough to truly protect it? Scientists don't yet have a clear answer, but if future observations confirm the presence of a robust magnetic field, it could increase the chances that this planet isn't just another lifeless rock, but a world with real potential for habitability. Understanding what the climate might be like on Proxima Centauri b requires more than just guessing. It requires detailed climate models. Scientists use these models to simulate the planet's atmosphere, temperature distribution, and weather patterns based on what we know about its size, orbit, and possible atmospheric composition. These models rely on physics, chemistry, and observational data to predict how heat moves across the planet, how winds might circulate, and whether conditions could support liquid water. However, these models come with limitations. Since Proxima Centauri b is so far away, scientists don't yet know whether it has an atmosphere, an ocean, or even surface water at all. They have to run different simulations, each assuming different conditions. Some models suggest that if the planet has a thick atmosphere rich in carbon dioxide, it could trap heat and create a stable climate, possibly allowing for liquid water. Others suggest that if the atmosphere is thin or non-existent, the temperature differences between the day and night sides would be extreme, making the surface far less hospitable. Because of these uncertainties, climate models for Proxima Centauri b predict a wide range of possible scenarios. In one case, if the planet has a dense atmosphere, global winds could distribute heat, and a temperate twilight zone between its scorching day side and frozen night side could support life. In another case, if radiation from Proxima Centauri has stripped away its atmosphere, the planet could be a cold, airless wasteland. Until scientists gather more data, these models offer glimpses of what might be possible, but they can't yet provide definitive answers. One of the biggest questions surrounding Proxima Centauri b is whether it could host life, and one way scientists search for signs of life on distant planets is by looking for biosignatures, chemical clues in the atmosphere that could indicate biological activity. On Earth, life has dramatically shaped our atmosphere, producing gases like oxygen and methane in amounts that wouldn't exist otherwise. If similar gases were detected on Proxima Centauri b, it could suggest the presence of living organisms. Scientists have proposed several possible atmospheric compositions for Proxima Centauri b. If the planet has a thick carbon dioxide-rich atmosphere, similar to Venus or early Earth, it might be able to trap enough heat to support liquid water, even in its tidally locked state. If significant amounts of oxygen were detected, it could indicate photosynthesis, the process by which plants and microbes on Earth produce oxygen as a byproduct. However, oxygen alone isn't enough. Non-biological processes can also create it, So it would need to be found alongside gases like methane, which is often produced by living organisms. Methane is particularly interesting because, in an atmosphere rich in oxygen, it tends to break down quickly. If both gases were present in large amounts, it would suggest an active, ongoing process replenishing them, something that, on Earth, is strongly linked to life. Other potential biosignatures include nitrous oxide, which can be produced by microbes, or even unusual chemical imbalances that wouldn't naturally occur without biological processes. Detecting these gases from Earth, or even with future space telescopes, won't be easy, especially given Proxima Centauri b's proximity to an active star. But if a future mission finds compelling signs of these gases in its atmosphere, it could be one of the strongest pieces of evidence yet that life exists beyond our solar system. When we think about life beyond Earth, we often picture something similar to what we know: organisms based on carbon, using water as a solvent, and breathing oxygen. But the universe is vast, and life could take forms we haven't yet imagined. On Proxima Centauri b, where conditions are far different from Earth, alternative biochemistries might be the key to survival. One possibility is life that doesn't rely on water at all. Instead, it could use other liquids, like ammonia or methane, as solvents for biochemical reactions. While water is essential for life on Earth, extreme cold environments, like those possibly found on Proxima Centauri b's night side, could favor ammonia-based life, which remains liquid at much lower temperatures. Another possibility is silicon-based life. While carbon is the backbone of life on Earth due to its ability to form complex molecules, silicon has similar properties and could, in theory, support biological structures under the right conditions. If Proxima Centauri b has a hot, mineral-rich surface, life could emerge in ways that don't resemble anything we know. Even if Proxima Centauri b is bombarded by radiation and lacks a stable atmosphere, life might find ways to endure. On Earth, extremophiles, organisms that thrive in extreme conditions, exist in deep-sea hydrothermal vents, frozen glaciers, and even radioactive environments. If life exists on Proxima Centauri b, it might be underground, shielded from stellar flares, or in deep oceans, surviving in ways completely different from anything we've ever seen. While we still don't know what's possible, considering alternative biochemistries broadens the search for life beyond Earth. If Proxima Centauri BE25T harbors life, it may not look like anything from our planet, but it would redefine our understanding of what it means to be alive. The idea that life could travel between planets, or even between star systems, is known as panspermia. This hypothesis suggests that microscopic life, or at least the building blocks of life, could hitch a ride on asteroids, comets, or space dust, surviving the harsh conditions of space and seeding new worlds. If true, it would mean that life on Earth might not have originated here, and similarly, life on Proxima Centauri b, if it exists, might have come from somewhere else. Space is full of debris moving at incredible speeds, and impacts between planets and asteroids are common. If a planet with life is struck by a massive impact, material from its surface could be ejected into space, carrying microbes or organic compounds along with it. Some of this debris could eventually land on another planet, potentially starting life all over again. On Earth, scientists have found bacteria that can survive extreme radiation, vacuum conditions, and deep freezes, suggesting that certain forms of life could endure interstellar journeys. If life exists on Proxima Centauri b, one possibility is that it arrived there through panspermia. Perhaps microbial life from a habitable planet in the Alpha Centauri system was ejected by an asteroid impact and later landed on Proxima Centauri b. Alternatively, the process could have worked in reverse. Perhaps Earth and Proxima Centauri B share a common origin, with life spreading between them in the distant past. While this idea is still unproven, it raises a fascinating possibility. If we ever find life on Proxima Centauri b, could it be related to life on Earth? Could we share distant biological ancestors across the vastness of space? Future missions and research may one day provide an answer to this cosmic mystery. The search for life on Proxima Centauri b is about to get a major boost from next-generation telescopes. While current instruments have helped us detect the planet and estimate its size and orbit, future observatories will take the search even further, potentially allowing scientists to directly image the planet and analyze its atmosphere for signs of life. One of the most promising tools for this task is the European Extremely Large Telescope, EELT, currently under construction in Chile. With a massive 39-meter mirror, it will be the most powerful optical telescope ever built. Once operational, it could be capable of capturing faint light from Proxima Centauri b and breaking it down into a spectrum, revealing what chemicals are present in the planet's atmosphere. If gases like oxygen, methane, or other potential biosignatures are detected, it could be the first real clue that life exists beyond our solar system. Other advanced telescopes, such as NASA's upcoming Habitable Worlds Observatory and future space-based missions, could further refine these observations. The James Webb Space Telescope has already demonstrated its ability to analyze exoplanet atmospheres, but Proxima Centauri b presents a challenge due to its small size and close orbit around a dim star. That's where the next generation of observatories will come in, using cutting-edge technology to separate the planet's light from its star's glare and reveal the hidden details of its atmosphere. If these telescopes detect a thick atmosphere, stable temperatures, and the right chemical signatures, Proxima Centauri b could become the most exciting candidate for an inhabited world beyond Earth. Until then, scientists are preparing for the moment when we might finally get a closer look at our nearest exoplanetary neighbor. Reaching Proxima Centauri b is one of the greatest challenges in space exploration. At just over 4 light-years away, it's our closest exoplanetary neighbor, but in practical terms, it's still incredibly far. The fastest spacecraft ever built, Voyager 1, would take over 70,000 years to reach Proxima Centauri at its current speed. Conventional space travel simply isn't an option if we want to explore this planet within a human timescale. That's where initiatives like Breakthrough Starshot come in. This ambitious project proposes sending a fleet of tiny, lightweight probes attached to sails propelled by high-powered lasers. These star chips could accelerate to 20% the speed of light, reaching Proxima Centauri in about 20 years. If successful, they could send back the first-ever close-up images of an exoplanet orbiting another star. However, this technology is still in early development, and major challenges remain, such as surviving interstellar dust impacts at extreme speeds and ensuring the probes can successfully transmit data back to Earth. Beyond the technical challenges, interstellar exploration raises ethical questions. If humans one day develop the technology to send larger missions or even colonize distant planets, should we? What if life already exists on Proxima Centauri b? Introducing Earth-based microbes could irreversibly alter its ecosystem, assuming one exists. And if we discover intelligent life, how should we approach contact? These are questions that scientists, ethicists, and policymakers will need to consider as technology advances. For now, Proxima Centauri b remains just out of reach, but that may not always be the case. Whether through advanced telescopes, robotic probes, or even human missions in the distant future, exploring this world could redefine our place in the universe and bring us closer than ever to answering the age-old question: Are we alone? Red. Dwarfs are by far the most common type of star in the galaxy. They make up about 70% of all stars in the Milky Way, meaning that if life can exist around them, the number of potentially habitable planets could be far greater than previously imagined. Studying Proxima Centauri b isn't just about understanding one planet. It's about unlocking the broader question of whether planets orbiting red dwarfs can support life at all. Unlike our Sun, red dwarfs burn much cooler and dimmer, which means their habitable zones are much closer in. Proxima Centauri b is a prime example of this, orbiting at just 5% of the distance between Earth and the Sun, yet still potentially within the right range for liquid water. If life can adapt to the challenges of these systems, such as tidal locking, strong radiation, and stellar flares, it could mean that habitable worlds are far more common than we once thought. Because red dwarfs burn for trillions of years, far longer than the Sun's expected lifespan, they provide a long window for life to emerge and evolve. If Proxima Centauri b turns out to have conditions suitable for life, it would suggest that countless other planets around red dwarfs might as well. In other words, studying this one world could be the key to understanding how life might exist throughout the universe. For centuries, humans have wondered whether Earth is truly unique or just one of many planets teeming with life. Studying Proxima Centauri b brings us closer to answering that question. If we find signs of habitability, or even life, it would suggest that Earth is not a rare exception, but part of a much larger pattern. On the other hand, if Proxima Centauri b turns out to be lifeless, despite sitting in the habitable zone, it could mean that the conditions needed for life are far more delicate and uncommon than we hope. Every exoplanet we study gives us a new piece of the puzzle. Proxima Centauri b is particularly important because it's so close, making it one of the best candidates for detailed observation. If we discover an atmosphere, liquid water, or biosignatures, it could mean that life has a way of finding a foothold in the universe, even in places very different from Earth. But if we find a barren, radiation-scorched world, it might suggest that Earth had an incredibly rare combination of factors that made life possible. No matter what we learn, Proxima Centauri b is a crucial stepping stone in our search for life beyond our solar system. The more we understand about this planet, the more we understand about our own, and whether or not life is something extraordinary or a cosmic inevitability. Proxima Centauri b is one of the most intriguing exoplanets ever discovered. As the i.e. closest known planet outside our solar system, it offers an unprecedented opportunity to study a world beyond Earth, one that orbits within its star's habitable zone and could, in theory, support liquid water. Yet, despite its potential, this planet presents extreme challenges. From intense radiation and powerful stellar flares to the possibility of tidal locking and an uncertain atmosphere, Proxima Centauri b may be far less hospitable than it first appears. Still, the possibility of life cannot be ruled out. If the planet has a strong magnetic field, a protective atmosphere, or underground oceans, life, perhaps very different from what we know, could exist there. Future telescopes and advanced missions like Breakthrough Starshot may help answer these questions, providing deeper insights into Proxima Centauri b's environment and its potential to support life. Ultimately, the study of this nearby exoplanet is about more than just one world. It's about understanding our place in the universe. If life can thrive around a red dwarf like Proxima Centauri, it could mean that habitable planets are far more common than we ever imagined. But even if Proxima Centauri b turns out to be lifeless, the search continues. The quest to find life beyond Earth is one of the most profound scientific endeavors of our time, and Proxima Centauri b remains a key target in that journey. Whether we find a second Earth or a harsh, uninhabitable rock, what we learn from this planet will bring us closer to answering the age-old question: are we alone in the universe?